Well, hello and welcome everyone. We're going to go ahead and get started on our presentation, the enhancements in Revit and Inventor 2022. If you have any questions throughout the webinar, feel free to enter those in the questions panel. We'll be attending to those as we can. So let's go ahead and get started. Again, today's topic is some new integration capabilities within Revit and Inventor. My name is Brian Verbort, and I'll be leading us through the presentation and demonstration of the capability. Pretty excited about what's capable or what's possible now with the Autodesk products. Even though we're talking about reaching across multiple disciplines, it's a reach that makes sense. So I'd like to start with just a preliminary introduction about who M2 Technologies is. We're US-based organization, and we're really just a technology consulting firm. Been in the business for a number of years, decades now. And we have locations across the US, but we're focused here with our headquarters in the Eastern Seaboard. We are a Microdesk partner, and that relationship gives us a unique perspective on the topic for today, which means we've got significant depth of bench when it comes to not only both the manufacturing industries, but also the design industries for construction. As mentioned, we are a consulting firm, and we consult with primarily manufacturers or building product manufacturers. We can handle all types of your needs for your organization as such, things like optimization and data management, manufacturing referencing, process improvement, whatever it might be that you need, it's likely that we can provide as a service. We have several industry partners. We can't be amazing at everything, and so we focus on our core competencies and partner with other organizations that have technologies and capabilities that they're able to focus on as well. We're a gold partner with Panzura for the synchronization of data across multiple sites. We also have obviously a relationship with Autodesk and Bluebeam. We're also glad to be a Cool Orange partner and the capabilities that their products bring to our data management environment, as well as connecting your organization to your data. I won't read through the list of services, but certainly speaking to some of our core competencies here, design automation and CAD management are a couple of the top ones. We deliver training to support the tools that you might have in place, and also provide you with product demonstrations and implementation for tools that you may wish to put in place. We have a focus on CAM and generative design, as well as standards development and simulation. With that introduction out of the way, hopefully you have an idea of what our organization is and does and is capable of. We're going to get started on the core presentation, focusing in on the capabilities, the new capabilities in Inventor as it relates to Revit. Give me just a second here, and I'm going to introduce my co-presenter here. I'm very pleased to be co-presenting with Paul Mumford at Autodesk. Certainly a knowledgeable resource, and we're lucky to have him here today. Paul, why don't you tell us a little bit about yourself and Autodesk and your position and Autodesk's position in industry.
Thank you for joining us today for this presentation on Autodesk Inventor and Revit Interoperability. My name is Paul Mumford, Technical Marketing Manager for the Product Design and Manufacturing Collection. Let me start by introducing you to Autodesk. At Autodesk, we make software tools that help our customers design and make anything, from skyscrapers to building components to bridges and blockbuster video games. We've over 9,000 employees worldwide and more than 18 million active users. And many of our customers are like you: architects, engineers, designers, manufacturers, and contractors. So let's talk about you. This is an exciting time to be a manufacturer in the AEC industry. The industry is big and it's growing, and you can see this growth all around us. New developments, new infrastructure projects, all being driven by global trends. Today, we have a global population of 7.5 billion, with 3.5 billion of us living in cities. And over the next 30 years, by 2050, it's predicted that 10 billion people will live on Earth, and 2/3 of us will live in cities. And all these people need communication and transportation, they need houses, bridges and roads, and access to power, water and data. But as we plan for the inevitability of designing and building more, how do we balance this with the reality of using less? We know our natural resources are diminishing and that our built environment is playing a role in all this. Buildings alone consume 25% of our water, and the building construction process produces 30% of our global waste. How will our industry meet the growing demand with fewer people to do the work, finite natural resources, in a way that generates less waste, has less negative impact, and leads to sustainable communities? These are questions we're asking at Autodesk because we believe that along with the inevitability of more and the reality of less is the opportunity of better. By improving our tools and technologies, we can embrace the opportunities ahead and overcome the challenges before us to make not just better products and better buildings, but a better world for all of us. So, how do you adapt or even grow your business against the background of doing more and doing it better whilst reducing impact? How do you provide choice to your customers without increasing the time it takes to prepare an accurate quotation? How do you increase flexibility in your design process without increasing your time to manufacture? And how do you manufacture increasingly complex designs efficiently and cost effectively? Because it's no longer simply about selling your product to the building industry. Your customers want your support to design better buildings, and they want your support to manufacture buildings that are more efficient and less wasteful to produce. Ultimately, it's no longer about selling your product or your service, it's about assisting to sell a great building which includes your product in it. One of the biggest problems facing building product manufacturers and contractors in the AEC industry is coordination and rework. Often, our profit margin is linked to the final payment, which is only received once our products are installed, commissioned, and signed off. And this can't happen if we deliver our products to the building site only to find they don't fit or there's an installation sequencing issue. To help answer this problem, with Autodesk Inventor 2021, we brought you Inventor AnyCAD for Revit projects. This gives us the ability to reference a Revit project into Inventor to use as a design reference. AnyCAD allows Inventor to reference a CAD file from many different authoring applications, including Revit. The CAD files can be edited in their original authoring tool, and when they're saved, the referenced model will update inside Autodesk Inventor. Referencing a Revit project into Inventor helps us to coordinate our model and make sure we have everything in the right place. In today's presentation, we'll look at some new functionality included with Autodesk Inventor 2022. And this allows us to complete the round trip, exporting a native Revit project file right out of Inventor. This allows us to easily communicate and coordinate our design with the Collaborative 3D Building Information Model, or BIM. Let's see how this might work in the context of an AEC project. We're going to imagine that we're working on a project and it's our job to coordinate the factory line equipment with the architectural model. Perhaps we're an engineering service provider who's responsible for specifying the equipment. Perhaps we work for different departments in the same company and we just want to make sure that our work is coordinated. We'll start by referencing the Revit model into Inventor, and then we'll use the Revit model to coordinate the placement of our manufacturing equipment. Next, we'll export our Inventor model as a Revit project, and we'll see how we can link the model into Revit for coordination and review. Finally, we'll see how we can use the Inventor model as a reference inside Revit and make a change to the Revit model accordingly. Let's start here in Revit. Here is the complete building that we'll be working in. We can also see a view of the area of the model where we'll be placing our equipment. We'll come back to this later. The Revit modeler has created a view of the model which isolates just the area we'll be working on in Inventor. This is helpful because it will reduce the load on Inventor while we work on the design. The Revit project file can be shared with us simply as a file, or it can be managed with Autodesk Vault, or coordinated via BIM 360 Docs. Let's move across into Inventor. We can start with a blank Inventor assembly file and we'll reference in the Revit model. We'll go up to the ribbon menu and look on the Assemble tab for the Place tool. We'll pick on the drop-down and choose Place Imported CAD File. We can now browse to the Revit project file that we wish to reference into Inventor. As the Inventor AnyCAD dialog opens, we'll notice we have the option to filter out any Revit categories that we don't want to bring through into Inventor. We'll also be presented with a list of saved views that are available within the Revit project. We'll pick Production B Coordination from the list and click OK. The Revit project is inserted into the Inventor assembly file just like any other component. We want to make sure that the coordinates of the Revit project match the coordinates in Inventor. So we'll right-click and choose Place Grounded at Origin. If we move our attention over to the browser, we'll see that the inserted Revit model has a small blue arrow icon. This indicates that the Revit model has been linked into this inventory assembly using AnyCAD. If the Revit file is updated, the referenced Revit file will update inside Inventor. We'll see how that works later in the demo. As we browse the model tree, we'll see how the Revit model is categorized, and we can drill down to the elements we're interested in. We can also select individual parts in the model and find them in the Revit category folder in the browser. Our next job is to place the Inventor model of our production line machinery into the design. To save us some time, I've already placed the models and hidden them from view, so let's make them visible. And of course, we could place relationships between the Inventor model and the Revit model, constraints, work features, sketches with projected geometry, confident that should the Revit model update, the AnyCAD reference here inside Inventor will update as well. Let's zoom in on our model, and we have a constraint we can drive over here. I'm sure you've already noticed, in the process of modeling our design, we've identified a clash. Now we could of course move the jib crane to another location, but let's imagine there's a good reason that the jib crane is where it is, and in fact, we're going to have to move the overhead ducting instead. So, how could we collaborate on this clash? Well, we could create a couple of screenshots and mark them up, or we could create a drawing of the area with some dimensions on it, or we could open our Inventor model in Navisworks and coordinate that way. But we're going to see how we can export our Inventor model as a Revit project, which can then be coordinated directly inside Revit. Before we export the model, let's switch views again. In this view, I filtered out people and vehicles, anything we don't need to bring through into Revit. And we also want to make the referenced Revit model invisible because we don't want to round trip that back into Revit. We may want to simplify our Inventor model further. Typically, we'll model our designs in Inventor at a scale of 1:1 with every nut, bolt and washer present. And this is way more detail than is needed for coordination on a BIM project. Our Simplify toolset is incorporated into the Revit Export command. So let's go to the File menu, the Export Flyout, Revit RVT. And we'll scroll down to the bottom of the dialog to look at the export options. We'll see that the file type is set to Revit RVT, and we can choose a file name and a save location here. Below this, there's the option to set the Revit BOM structure. This setting is relevant to the ability to tag and schedule the components in our design once our model ends up inside Revit. All in one element means that our Inventor model would appear inside Revit as one lump. Each top-level component means that our Inventor model would appear inside Revit as individual components that can be tagged and scheduled independently. Now let's go back to simplifying the geometry of our model. Up at the top of the dialog here is the option to replace our model components with envelopes. We can choose to export one big bounding box that incorporates all of our model, or we could choose to export each top-level component as a bounding box, or we can choose to export every part as a bounding box. Rather than simple bounding boxes, we can use the controls below to remove detail with greater precision. We can choose to remove components by size, or even remove individual features. We could choose to remove all holes, for example, or all fillets, and we can filter our selection by size, or even preserve features that we don't want to be removed to make sure they're available for coordination. So, at the beginning of a project, when you're just space planning, the top-level bounding box for each component might be all that's needed. As the project progresses, you can choose progressively finer amounts of detail to include in your model, depending on the requirements in the BIM execution plan. At the top of the dialog, we have our presets. This allows us to save the selections we've made in the Simplify and Export dialog, allowing us to reuse the same settings across multiple designs, or even standardize our export settings per project or company-wide. Now, I'd like to show you a different method of simplifying our model. Rather than using the top-down approach, simplifying our model after it's complete, we're going to show a bottom-up approach, designing our simplified state into our model as we go along. In this example, I've used model states in Inventor to create a simplified version of each component, which can be triggered from the top-level assembly. This allows the finest possible control over which features are exported to Revit and allows support for the inclusion of additional features, such as exclusion zone geometry. So we've set our output options, our BOM structure, and simplified the geometry, and we're ready to click OK and export our Revit file. Our Revit project file is now being generated, but before we take a look at it inside Revit, let's just take a quick look at the Inventor browser. You should now see a new Revit Exports folder has been added to the model browser, containing a node that represents our Revit export. If we go up here and right-click on the Revit export, we'll see we have a couple of options. Update allows us to re-export an updated Revit file from this model using exactly the same Simplify settings. Edit Simplify allows us to change the Simplify settings we chose last time before then outputting our updated Revit model. Both options will overwrite the existing Revit file, which can then be updated inside Revit. If we produce multiple Revit exports from our model using different file names, we'll see multiple nodes in this browser folder. This could be useful if you need to send out different versions of your design with different detail levels or different configurations. Okay, let's jump across into Revit and we'll see how we bring in our Inventor design. Here we are back in Revit. We want to see what happens when we bring our Inventor file into Revit as a Revit project, and we'll do that using something called linking. So we'll go up here to the Insert tab and we'll look on the Link panel for the Link Revit command. And we'll click on Link Revit and we can browse to the Revit project file that we exported out to Inventor. We'll select the file and pick Open. And because we created this model in Inventor using the Revit model as a reference, you can see the coordinate system of the two models line up perfectly. This allows us to coordinate our design in Revit and examine it against the original design model. All the models of the other trade contractors are also going through the same coordination process. So, here is the clash we identified inside Inventor. Let's see how we can fix it inside Revit. Let's take a look at our 3D view and 2D reflective ceiling plans side by side. And we can select here the duct we want to move, and we'll see it highlight in our model in both windows. I'll select the dimension it needs to change and type in a new figure. And we can see that the duct has moved and it no longer looks like it's causing a clash. Now, we want to be able to round trip this back into Inventor. And to do that, we'll save the Revit model. And back in Inventor, we'll see a lightning symbol next to our reference Revit model. And we'll also see the Update button is highlighted. It looks like a lightning symbol over a piece of paper. And that's because of the Anycad system, meaning that when the Revit file was saved, it's triggered this update inside Inventor. So we'll click on the Update button to receive the update, and we'll see whether the clash has been resolved. So, the update is done. Let's swing the jib crane round again and check that we have clearance, and that looks good. So the clash is resolved, and we're ready to move on to our next task. So, to recap, we've brought a Revit model into Inventor and used it as a design reference for laying out the machinery in our facility. And now we have everything we need to procure or manufacture the equipment in our process line. But before we do that, we still need to go through the coordination and approval process. One advantage of the BIM workflow is that we exchange the 3D model rather than just the 2D drawings. And thinking about our customer for this model, we used our built-in model states to simplify the design to show just the level of detail that's appropriate for this stage of coordination. We were then able to bring the Inventor model into Revit, check the design for fit and sequencing, and make any necessary changes to the building systems to ensure the design is coordinated and ready to be released for construction. Finally, we saw the update to the Revit model inside Inventor, so we can be reassured the coordination has been done and we can move on to our next task on this project. Now, Inventor can export files for BIM coordination in RVT, Revit Project, RFA, Revit Family, and IFC format. IFC is Industry Foundation Classes, which is a BIM-neutral file format. The Autodesk Product Design and Manufacturing Collection also includes Navisworks, which is often used in the AEC industry as an on-premise coordination tool. If you're required to supply a Navisworks file, that's NWD or NWC as a project deliverable, it's as simple as opening the Inventor file in Navisworks, saving the file, and issuing the Navisworks file for coordination. Your RVT, IFC, or Navisworks file can be managed locally with Autodesk Vault and manually uploaded or automatically synced to BIM 360 Docs, which provides BIM coordination and review tools in the cloud. So what we've discussed today is a very specific workflow between Autodesk Inventor and Revit. Obviously, there is much more to building component manufacture than coordinating the design. What we haven't had time to talk about is Autodesk Inventor as part of the Product Design and Manufacturing Collection, helping you with the end-to-end workflow from initial concept design through to the manufactured product, supported by data management in Autodesk Vault and process management with Fusion 360 Manage. The collection includes the design and automation tools in Inventor, plus advanced simulation for testing your designs, nesting, and 2.5 to 5 axis CAM for manufacturing output, and factory layout tools to help you optimize your production facility. It's an end-to-end solution that works right inside Inventor, along with complementary tools like AutoCAD, Fusion 360, and Vault. So if you're getting involved in BIM projects and evaluating ways to improve your development process in any of these areas, we'd love to discuss how we can help. Now, I'd like to leave you with this quote from one of our customers, Andrew Cullum of Polypipe Civil Engineering. Creating product files that are BIM ready is obviously important for ensuring that we're in step with our construction clients and meeting their needs. But actually, having a better, more consistent approach to how we integrate our products in project designs and manufacture products also opens up a lot more opportunities for us as a business.
Thank you, Paul, for all that information. A bit of a whirlwind tour, but I think it exemplifies the workflow. It's been broken for so long. I don't know any of us expected to actually see it loop back. And with the release of the Inventor 2022 and Revit 2022 versions of the product, we have that full round trip now. We can reference model types from the two different CAD systems for our own purposes and using our own workflow and techniques to meet the needs that we might have. I'm going to take a look at the questions panel here to see if there are any questions that are being asked. And while I'm doing that, I'd like to thank you for attending today and encourage you to include us in any of the discussions you might be having about your business process, whether it be specifically related to your CAD tools or anything else actually related to your process, interaction with vendors, suppliers, training needs, whatever it might be. We'd be happy to help you. We do have a unique position in industry. We speak to a lot of different customers. It's likely that we may even be speaking with your competitors. We'd love to tell you how they're making progress and how you could be making progress as well. Sustainability is a big thing these days. It's very important for us and our children and our grandchildren to be left with a world that is in a sustainable state. I encourage us all to do that. I appreciate the time today. Thank you for attending. With that, I'll leave you with some contact information. And again, encourage you to reach out to us. Or if we reach out to you, maybe take that phone call today. Thanks for your attention. Thanks for your patience. Have a great day.